Good morning. My name is Enzo Martinelli. I'm professor of structural analysis and design at the University of Salerno, Italy, which is the coordinator of this project, Recycl3D. This is an outline of my presentation, which is on purpose longer than what can be included in a 5-minute speech, but I'll try to browse through it in order to give you the big picture of the project. What this project is about. This project is about trying to give value to the fine fraction of recycled aggregate, which is currently, it's recycled concrete aggregate, which is currently discarded, which is currently landfilled. So now we would like, our aim is to utilize the fine fraction of the recycled aggregates as a constituent for the paste to be utilized in 3D printing concrete procedures. To do so, we have a multidisciplinary consortium, international consortium, made of the majority are from Europe, but we have also some American partners. We have partners from academia, we have partners from outside academia. This is the project budget, which includes also a significant co-funding. The project partners, several project partners have been already collaborating among them as part of previous research projects financed by the European Union, and also as part of working groups, for instance, in this FIB. FIB is the International Federation of Structural Concrete. The project is clearly interdisciplinary because it includes partners with expertise from mineral technology up to structural engineering. So all the range of the expertise in construction are covered, and we have several stakeholders from the association of the European Aggregate Association to mineral technology centers, companies producing aggregates, and also concrete producers and construction companies, big construction like Acciona, for instance, are part of these stakeholders. This is once again the specific objectives. So trying to characterize this fine fraction of recycled aggregates, come up with mixed design rules for the 3D printed paste. Design also the overall sustainability-based framework, and also once the 3D printing 3D printed artifact is produced, also to try to figure out an end of life for these artifacts based on deconstruction, recycling, recovering, possibly repurposing. Why not? And to do so, we are also preparing some prototyping and industrial demonstrators. This is the conceptual sketch about our activities. You have to figure out here an axis of time. We are more or less at the end of these 3 fundamental activities about the behavior of the material we are handling, and now we are going to start with the prototyping. We already started, actually. We are a bit ahead schedule on this. These are how the manpower effort is distributed among partners, and these are some example of activities. We have, for instance, methodology. We have, for instance, sampled different aggregates, recycled aggregates. These are the ZUT means the Polish partners. This is from UNISA, from my university. These are from the UPC, from Barcelona, Politècnica, Catalunya, and all these different diverse materials have been treated with the same unified approach, with the aim to identify whether they have the fundamental properties to be exploited and utilized as 3D printing material constituents. 3D printing activity itself is mainly in charge of several partners who are now developing both the device and also investigating the material, the paste, both at the fresh state and the hardened state. And here you see how the first printing of this material, including fine recycled aggregate, look like. This is also some prototyping of the material. The main feature of this is that we don't have solid items, but we have some truss-like arrangement, which makes things more efficient. These are the publication, and now the work ahead is partly dealing with modeling and partly dealing with the demonstration. We have already, you see how our 3D printed demonstrator is going to employ 60% of the material that would have been employed for a monolithic, traditional monolithic item. The 3D printing has been already done with, by using the traditional 3D printing paste. Now we are going to utilize the same procedure you see here, but with the recycled aggregate paste. So this is the work ahead, and we are going then to finalize our project, which is intended, as I mentioned, to demonstrate the feasibility and the advantages of using this fine fraction of recycled aggregate as a constituent for 3D printing concrete structures. Thank you very much for your attention, and we look forward to presenting you future development of our research.